Morning, everybody. How are you all? Good? Learning heaps of stuff so far? Excellent. Well, thank you for coming along. My name is Damien Brady. I am a cloud advocate for Microsoft, which means that I come to events like this. I get to talk about some really exciting stuff like DevOps, which is kind of my area. Today, I'm going to be talking about deploying your application faster and safer. So before we start, I thought rather than just go into all the details about what's involved and why DevOps is important and stuff, I thought I'd start instead with a little video which demonstrates a bit of the idea of what DevOps is for. So why DevOps is important and what things can look like before and after DevOps. And this is an analogy, so bear with me, but I think this is a really good demonstration. So let's just have a watch.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch.
The thing I love about this video is it's uncomfortably long.
Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
So just 67 seconds. So this is the before DevOps, right? So now we're about to see the after DevOps. Right, so there's a small difference. The good thing about this is whenever I show that video, people will come to me and say, look, Damien, that's not really a fair comparison, right? So back in 1950, they were only allowed to have 4 people involved in this pit stop. So only 4 people were allowed to be involved in getting the car back on the track, which is what the entire team wants, right? What else was there? There's taking the tires off. They have this new technology where they can just like a single nut and then pull it out, change the tire, put a new one on, and it's done in a couple of seconds. They didn't have to refuel in 2013 either. And in fact, I think recent rules, they're not even allowed to refuel, if that's correct, yeah. So all of these things are very, very different between the way they used to do it and the way they do it now. So not a fair comparison. And I say, yeah, that's exactly right, it's not. But that's kind of the point, right? You've got this entire team of people who really just want to get this car back on the track, but you're only allowed to use 4 of them. Like, if you have a skill set that can be used to get this value back in the team, like the car back out on the track, why not use it? So that, I think, is a pretty good analogy for DevOps. What else was there? There's the refueling. And this is a bit analogous to changing the architecture of your application so that you don't need to do as much work. You don't need to refuel. You can just swap out bits of the application that you need to change. Like, you don't have all of this downtime. You can deploy a new car and then swap them out, potentially. I think that's coming in future rules. So there's that. And then the last one, like the tires, taking the tires off, right? There was somebody who was physically hitting that tire with a hammer to get it on, right? Which I think is perfect. So I did this kind of stuff for ages, for about 15, 18 years. And can anybody tell me that they haven't deployed something to production and then hit it with a hammer to get it to work, right? That's a perfect analogy in my mind. Right? So yes, things are very, very different than the way they used to be, but that's kind of the point. So this is the idea of what DevOps is supposed to be able to do for you and how it can improve the situation to get that value back on the track as soon as you can. So I've talked about DevOps a couple of times. I've mentioned that word, but I haven't really defined what DevOps means. The good thing about DevOps and also the bad thing about DevOps is it really depends on your perspective, where you come from. I come from a software development background, so when I think about DevOps, I'm really centered around getting software out the door and into production, so that deployment cycle. But somebody who has an operations background thinks about DevOps as maintaining availability in standard operating environments and being able to swap out environments really quickly and safely and things like that. And nobody's wrong necessarily, right? We all just have different perspectives on what DevOps actually means. At Microsoft, though, we define it fairly broadly. So the definition that we use at Microsoft is that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Now, notice I said continuous delivery of value, right? Not continuous delivery of features or continuous delivery of work items that are on the backlog, right? Continuous delivery of value. And the only way to know whether you're delivering value is to actually measure it when it's in production. If you work on a feature and push that out the door and it takes you 6 months and it's in production but nobody uses it, you haven't delivered any value. You've delivered a feature. So measuring what actually happens in production and whether what you're providing is valuable is really, really important. There's a very big difference between saying to somebody, remember that feature you worked on for the last 12 months? Yeah, it turns out customers don't use it, we're going to scrap it. And saying, remember that feature that you started working on a week ago? Turns out people aren't going to use it the way we expect, so don't worry about it, we'll move on to the next thing. Right? One of them is a huge waste of time, and the other one is a little bit more agile, and this is what DevOps allows us to do, move a bit faster but safer to measure that value that's in production. So the other question that we get as well is, why is it important to do DevOps? Like, what's wrong with actually deploying every 3 months and just making sure you survey your customers ahead of time to make sure you're working on the right things and so on? The short answer to this is it's important because your competitors are already doing it. So if it takes you 3 months to fix a bug or to make a change to a feature that makes it more usable for somebody, and it takes your competitors an hour to deploy that fix, where do you think your customers are going to go? You're going to start losing customers. You're going to be out-innovated by your competitors. And even if your customers are not the end users or the end customers of your company, if your customers are an internal team in your organization, that department is going to start having trouble keeping up and keeping their customers because the software that you provide and the infrastructure that you provide is not able to be agile enough, right? So even if you're internal and not dealing with customers directly, this still applies. Right. So DevOps allows you to be a bit more agile, increase the velocity, so actually get your stuff out the door much quicker. And it does that by allowing you to reduce downtime and reduce human error. So never send a human to do a computer's job, right? We make mistakes a lot, right? So reducing that downtime and fixing things much faster, allowing you to reduce human error is really, really important. And that enables you to stay up with the competitors and hopefully ahead of your competitors as well. So the other part of that, the other part of this as well is that quite often when I say these things, people will say, well, that's just your opinion. Is there anything actually behind this? And the answer is yes. There's a really good report that I always refer to called the DevOps Research and Assessment. That's the organization that publishes this report. The report is the State of DevOps report. And it's a very digestible 70-odd pages report that comes out every year. And the way they put that together is they survey tens of thousands of software delivery teams, and they do some cluster analysis, and they group them into high-performing DevOps teams and low-performing DevOps teams and medium-performing DevOps teams. There's a little bit more nuance in the report, but in general, they compare the high-performing teams to the low-performing teams. And what they find is the high-performing teams deploy, on average, 46 times more frequently. So they deploy more often. The lead time for changes is lower. So that's the time from when they actually make the change in the code and have that running in production. It's 2,500 times faster than a low-performing DevOps team. But then, and in some organizations this is counterintuitive, the changes that they do make fail less frequently. So there's a 7 times lower change fail rate. So the stuff they're putting into production doesn't break as much. And when it does break, they can fix it 2,500 times faster because they've got this process that enables them to fix these changes, push out to production and repair things. Now, this is real good academic research, right? There is real stuff behind this. This report is a fantastic thing to show your manager if they say, yeah, we've given DevOps to you as a title change, but please don't do anything different. We still deploy every 6 months. Right? This is a great way of convincing them that things actually need to change. So I'd highly recommend looking at that report. The other part of that definition I showed you as well was about people, process, and products, right? These 3 parts to successful DevOps. So people is kind of where I want to start. So traditionally, in software development and software delivery, the developers would write some code, they'd maybe package it up, they'd throw it over a wall to the operations team and say, here you go, deploy this. Here's a Word document that we last updated in 2004. It's probably mainly right. Deploy the application and then maintain it. And this leads to a lot of problems. Developers start blaming operations because they didn't install things properly. I mean, it's a .NET application. Of course, you need the .NET framework. I didn't need to put that in the document. Operations teams blame the developers because every time something changes, it breaks production, right? So you get these 2 teams in the same organization who are supposed to be working towards the same goal, working software in production, but they are working at cross purposes. So what I mean by that is developers are incentivized on change. Everything a developer does is change. You're adding a feature, you're fixing a bug, you're re-architecting some stuff, you're changing things. So that's their incentive. Operations are incentivized on the exact opposite, on stability. And what hurts stability more than change, right? So keeping things available, the easiest way to do that is to not change anything, right? So you have these 2 teams who are working directly opposite purposes. So that's your first challenge, is to get these 2 groups, these 2 disciplines to work together for the same goals, deploying faster and safer. So that's the big thing. To do that, you kind of need a decent process, right? You need to be able to handle your development, so your planning, your development and testing, your release out to production, and then don't stop there. You need to measure what's happening in production and use that feedback to come back to the planning in the future as well. And DevOps is about doing this fast and safe, right? Having a process in place that enables you to do this without thinking about it. To do that, you kind of need some good tooling around it. Now, the good thing about Microsoft is it doesn't matter which area of DevOps you're talking about. So the planning and tracking of your work, the development and testing, the release, and then your monitoring and learning. There's all these different things that you have to do at these stages. But the good thing about the current Microsoft is we don't force you to use our tools for everything. So if you have investments in any of these tools or any other tools that help you with your DevOps process now, we are working hard to make it easy to continue to use those tools. And Azure DevOps is the product that can kind of fit in and add those functions at the gaps that you have. So Azure DevOps itself can do everything for all of these stages. Like we work really hard between Azure and Azure DevOps to make sure we cover all of this. But if you use these tools already, then you can continue to use those tools. But as I said, Azure DevOps is designed to do all this as well. And it's designed for any language and any platform too. So we're not talking about just Windows and just .NET. We're talking about any language running on any platform. You can run Python on a Raspberry Pi using Azure DevOps, and I've done that before. It's fun. Somebody asked me whether you could do COBOL. Don't know, probably. But basically anything that you want to do in any language, targeting any platform, whether it's Azure, on-premises, behind a firewall, on somebody else's cloud, Azure DevOps will support you there. So Azure DevOps itself is a collection of 5 services, 5 tools. Azure Boards to manage your work item tracking and the work that you're actually doing, issues and bugs and things like that. Azure Pipelines is all about continuous integration, continuous deployment, or continuous delivery. Azure Repos is where you can store your code if you want, but we also have incredibly good first-party support for GitHub, and then really good support for any other code repo that you have your code in as well. Azure Test Plans for managing your testing efforts, and Azure Artifacts for storing your packages and things like that if you have them internally as well. What we're going to focus on today, because we're talking about delivering faster and safer, is really going to be around Azure Pipelines. And in fact, I'm not even going to have my code in Azure Repos. It's open source. There'll be a link at the end so you can download it if you want to anyway. So we're going to put it in GitHub. Well, that's where the code lives, in GitHub. So we're going to focus on Azure Pipelines. Now, it goes without saying as well, this is part of Azure. So Azure DevOps itself and Azure Pipelines and all of the other ones work really, really well with Azure. That integration is really tight. So I think that's probably enough talking about stuff. The rest of the session is really going to be demos, actually walking through this. And we'll start pretty much from scratch. We have the repo in GitHub, but we're going to build a full continuous integration build definition, and then continuous delivery and continuous deployment to a few different environments, and make sure we're deploying not only faster, but deploying safer as well. So we'll start talking about that too. So let's get started. And this is a long room as well. So if anybody at the back can't read anything at any point, can you please just raise your hand? I'll keep an eye out and I'll zoom in if I need to. So is this okay for everybody at the moment? Good? I can see a hand. I probably didn't do that very well. Put your hand up if you can't read that. Okay, I'll zoom in a bit. This is actually not very important, this bit, but this is the GitHub repo where the code lives, right? And it's a Node application, a Node front end that we're looking at. And if you've been to any of the previous sessions in the learning paths, you might have heard of Tailwind Traders. So this is the Tailwind Traders front end application. At the moment, it just looks like this. Oh, that did it twice. Doesn't look like that. Although that would be a good starting point, I suppose. So this is the Tailwind Traders application, and it's just the different products that they're selling and so on. Not terribly important, but this is what we're looking at the moment. Right, so we have our code in GitHub. The first thing I want to do is I want to build a build environment. I want to define a way of building this application so I can determine the code changes that I make and my team makes can still compile, can still end up with a real product. So the really good thing about GitHub is that we have a GitHub application now. So if you go to the marketplace right from your GitHub repo, and I'm just going to search for pipelines and scroll down a bit. So Azure Pipelines, which now has 12,500 installs, is the application that you can add to your GitHub account to give Azure DevOps and Azure Pipelines access to your code base. So I've already set this up, but it gives you a bit more information about what you can do. Hosted Linux, Mac, and Windows agents as well. But here's a really cool part. The pricing is $0, which is reasonably cheap. And that's free for public and private repositories. So with public repositories, with open source applications, you get unlimited build minutes on our hosted agents, and you get 10 free parallel jobs at a time. So you can run 10 builds at the same time for free with no limit to the number of minutes that you use on any of those platforms, Mac, Windows, or Linux. If you have a private project, it's 1,800 build minutes per month and one job in parallel. So it's still free to a point. And then you can pay more for more parallel jobs and things like that. So I've already set this up. So I just need to configure Azure Pipelines, this application, and then just give it access to the repo that I've created, or the repo that has the code in it. So again, there's a bit more information about what it can do. I'll leave you to read that later. It tells you what permissions it needs, and then you can either give it access to all of your repositories or just select repositories as well. So I've got a few, but I also want to just add this Ignite Tour repository that I've got as well. So I'll add that, I'll save it, and this will take me into a flow which enables me to actually build my pipeline really easily as well. So just to let you know, it's asking me to log in. Hopefully I won't need to give any passwords or anything. And then it will ask me what organization, what Azure DevOps organization I am going to use, or do I want to create a new one? So I work for Microsoft. I have a couple of these. So I'm just going to choose an existing one. But you could create a new one straight away. And then I'm actually going to use an existing project. But again, you could create a new project. So the organization is like your account, and the project is the project that you're working on at the moment. So I'm going to use Abel Tailwind. So Abel actually originally wrote this demo, so I'm just going to write all over the top of his stuff. I'm sure he won't mind. So let's continue that. It'll take us to Azure DevOps. And the next thing it wants to do, now that we've connected GitHub and we've connected Azure DevOps or Azure Pipelines, is we want to choose the repository that we're going to deploy. So this is the one that I just added. I'm going to zoom in a bit. This is the one I just added, Ignite Tour LP1S2. So let's choose that. It's giving me a warning about the code being public, but the pipeline being private. So I'll just ignore that for the moment. And what it's done is it's looked in my code and decided it thinks I've got a Node application. So that's the recommended pipeline template that it wants me to use. But it also knows that a Node one could be with React, Vue, Webpack, an empty one, or a minimal pipeline, or an existing YAML file, so an existing definition, or any of these. So there's all of these templates that know how to build various different things. So right out of the box, you can choose one of these templates, but this is a Node application. I'm just going to use their standard one. What it's given me now is a definition of how to build a Node application. Now this is really basic. It's basically just using an Ubuntu 16.04 agent, so a Linux agent. It's doing a install Node.js spec. So it's saying, you're going to use 10 point whatever. And then it's just doing npm install and npm run build. And that's all it's doing. So this is really just going to compile my application. If you want to know what other tasks, what other pieces of YAML you can use, there's a link to docs, which tells you everything that you can put in here. Or that link here, which gives you a link to the docs, but specifically for JavaScript. So that narrows it down a little bit more as well. There's also, and this is relatively new, there's also IntelliSense in the browser and autocomplete and things like that. So that's really handy as well. That gives you a bit more help. Oops, saving is not the right thing. So I've got this basic build. I'm going to save that and run it. And what it's really doing is it's creating an Azure pipelines.yaml file, the definition, and it's adding that file to my repository and it's committing it to the repository itself. So when somebody gets my code, when somebody pulls down the new version of my code, they not only get the code, but they get the definition of how to build that code too. So that if they need to make a change, they need to build a new project. They need to add some scripts or something to that build definition. That lives alongside the code. And there's huge advantages to this. One is if you have a feature branch, for example, that is going to change the definition of your build. You can change the definition in that branch. So you're not affecting the master branch that everybody else is working on. The definition of how to build this change is alongside that change, which is really handy as well. The other thing that it does is it actually sets up this build as not just a continuous integration build, but it sets it up in GitHub as a GitHub check or a PR check. So if we go to GitHub, I think I can do that. There we go. If we go to GitHub, and I'm just going to look at some previous pull requests just to show you what I'm talking about. Here's a PR test. So this is a previous pull request that we've since merged and closed. But you can see the checks tab right here. If I choose that, you can see at that point, it actually ran an Azure Pipelines build. So when somebody submitted a pull request, and this is really handy for public projects, when somebody submitted a pull request, it ran a build to make sure that the code they'd changed was still going to compile according to our build definition. You can use a different build definition for this as well. So it doesn't have to be your full definition of how everything works. It could just be maybe a compile, and that's it. That's all you want to do. Or maybe just some linting to make sure that they're following your standards in your application. So that can be a check to make sure that what somebody has submitted is not going to change. All right, so this is doing a checkout. This has actually started taking a little bit longer than it had been. So we're at 66%, and we have been for a while, which is fun. And no, I haven't checked in the Node packages. So we'll let that run. So this is just going to do a straight build, right? It's going to compile my application, but it's not going to give me any artifacts to deploy. It's not going to run any tests. It's not going to set any configuration. So I want to add that functionality. I want to add some more stuff to it. There's the YAML definition that you can use, so this text-based definition. But if you're familiar with Azure DevOps or Visual Studio Team Services, which is the old name for it, you'd probably be familiar with the visual editor. And you can still use that. So when you create a new build pipeline, you can choose, once you choose the location, before you choose that location, you can actually use the classic editor, which is the visual editor, and that will give you a UI-based way of building your application, your build definition. So let's just jump to one that I've created earlier. And so this is exactly the same thing. It's just a visual way of defining it. So I can add and remove tasks, and out of the box there are thousands of tasks that you can use. Actually, probably not thousands, many, many hundreds of tasks that you can use. And if what you want to do is not out of the box, there is also the marketplace. And our partners have created well over 500 tasks, build and release tasks that you can use. If what you want to do is not in either of those, you can either write your own script. So you can write a bash script, for example, or a PowerShell script, or a Azure CLI script, or something like that. Or you can write your own custom task and either add it to the marketplace if you want, or just add it to your own project in your own organization. So you can really get it to do anything that you want. Remember, we can run on Windows, Linux, or Mac OS as well. So this, at the moment, is set to use the hosted Ubuntu 16.04 agent, but I also have access to a hosted Mac OS agent. Let's just do that drop down again. Hosted Mac OS agent, Ubuntu 16.04, VS 2017, VS 2019, a Windows container, or I can use my own agent pools if I want to install an agent on my own system or my own infrastructure, which maybe has some third-party tooling installed or access to different parts of the network that the hosted agents are not going to have access to. So I have that option for me as well. So you can really do whatever you want, and then when you're done, you can actually come to the agent job itself and click View YAML, and it will give you the YAML equivalent of this visual UI. So you could copy and paste that into your definition and actually have that live alongside the code as well. So let's actually do that. I'm just going to copy that to the clipboard, and we'll jump across. I'm just going to do a git pull, and you'll see that now we'll have an Azure Pipelines YAML file. Let's zoom in a little bit more. So this is the one that it added out of the box, the default one. But I want the one that I just created. I just copied from the clipboard, right? So we're using that same agent. We're doing an npm install. We're doing a bunch of bash scripts. We're packaging up the file itself. We're zipping it up. And then we're copying it up back up to Azure DevOps so we can deploy it later on. So I want to save that. And this is just a file in my repository. So I've updated that file. So let's commit that and push it to Git. And we should see, hopefully, in our builds, yep, I didn't need to change anything, that it's still running that first one. Let's see how far along it is. It's still checking out, it's still at 66%. That's not a great sign. Oh no, we're good, all right. But in the meantime, I'm going to cancel that one. And we should see in our builds, it's going to pick up the new build definition, that new one that I just created, that change. And we can follow that one through if we want. It's going to do the same thing. And it's probably going to take a little bit longer than I wanted to as well. So we're going to move on. Before I do though, does anybody have any questions about what I've shown so far? We've really got this build definition that knows how to build our application. And that definition lives alongside our code in that code base. Yes?
Is it possible to run the definition on my working laptop?
So the question was, is it possible to run that build definition on your working laptop, so you're on your development laptop? And the short answer is no. Part of the reason is that you can, in your build definition, have multiple jobs that run on different operating systems that require different things. It's not quite as simple as running all of these tasks one by one. It's running all of those tasks on different environments in different locations. So you may have tasks that run on a Windows machine, tasks that run on Mac OS, and so on. So that kind of thing wouldn't be running locally on your local machine. If you wanted to actually run those builds on your local machine, you could set up an agent and have that in your private agent pool, and then it will physically run on your machine, but it'll still act like an agent of Azure DevOps. So you can see what it's doing, but it's not a command line, compile this thing for me. Does that make sense? Cool.
If you have running already built definitions and you're using the VSTS file share, can you migrate those to the structure to bring the YAML file with the code? And
So the question was if you have it locally?
now if you've already defined the build
Oh, yep.
in DevOps, and you want to migrate to it, bring it to the code and make it part of the check-in in Visual Studio.
Okay, so the question is if you already have that build definition in YAML.
In DevOps, but not on the source code side.
Oh, in the visual UI?
Yes, yes.
Yeah, in VSTS. Yes, so that was the question, just to paraphrase, was if you already have that visual build editor, that visual build definition, can you pull that into your source code? And yes, that's the one I showed just before, where if you have that visual example, you can grab that job and view the YAML, copy and paste that. This doesn't actually move though. You have to create a new job for it. Yeah. So you would lose your history. You can keep this around and then just remove all the triggers. So you have the history there, and then going forward, you have the new build definition. Now this is actually completed, so I'm going to move on. So we've got this build definition. So we can see all of the stuff that happened, and we can see the summary as well. And the good thing about this summary is that we've got this build artifacts published section. And I'm going to just start zooming in like this because I think that's a bit easier. So this is the drop folder. This is the thing we uploaded to Azure DevOps. We can look at the contents or download it. But if we look at the contents directly, we can see that all we did really, because we zipped it up and then pushed that up to Azure DevOps, we now just have a zip file which has our compiled node application. That's the thing that we want to deploy to Azure itself. We can also see that it succeeded, we can look at the logs, we can see the associated changes, and that will give us a deep link all the way back into GitHub as well, so we can see the commit that made that change. And if we have things like unit tests, we can also get test results in there as well. And you can see analytics over how those tests have performed across the last few builds. I don't have any at the moment, so that's not going to give much. And then there are extensions that can give you other things, like build reports from WhiteSource, which looks at your dependencies of your application to determine whether there are any vulnerabilities, for example. So that is an extension that you can add to Azure DevOps to enable you to get that extra information as well. But I want to deploy this now. I've got my build, I've got my artifact, I've completed it. So I can click on this release button up the top, and it will start to fill out this release definition for me. Once again, I have templates that I can use. I can deploy a Node app to Azure App Service, PHP, Python, Kubernetes cluster, all sorts of stuff. I'm just going to do a straight Azure App Service deployment though. So let's apply that template. And let's just kill that for the moment. It's set up this pipeline where we're starting with the artifacts. This is the artifact from the build. We're doing a continuous deployment. So there's a trigger on it to say every time there's a new build artifact, a new result from my build, start this process. And then right now we have one stage which has one job and one task. And at the moment, it's waiting for me to give some more information. So let's just rename this to staging. Oh, no, thank you. Let's just rename this to staging, and we'll change the tasks that are in there. Now this will probably look familiar. This is exactly the same engine as the build. It's basically a task runner that runs one task after another on a particular agent. You can add more agent jobs. So you could run some on Windows, some on Linux. You can add a deployment group job, and I'm not going to go into this right now, but that's the way you can deploy on premises. You can add a job which deploys to all of your web servers, and then have 10 web servers in that deployment group. And it will run that task on all 10 of those machines. Right? Or an agentless job. If you just want to do something like call an Azure API, you probably don't need to run all of that stuff on an agent itself. You can just run it straight from Azure DevOps. The settings that it needs right now are the Azure subscription that I'm using. I've already set one up. So there's a subscription to where I'm deploying it to. But if you don't already have one set up, these are the available Azure subscriptions that are tied to the same account I'm logged in as. So there's one for that subscription itself. There's some for my CDA, my Cloud Advocate groups, all sorts of stuff as well. If I chose that, I could click the button to authorize this, and it would just set up a service principal which does the authorization scoped to that entire subscription, which I probably don't want. So I can look at the advanced options and restrict it to, for example, a resource group and say, this connection, this build definition, or this release definition can only deploy to stuff in this resource group, which is a great way of kind of reducing what we call your blast radius. If somebody manages to change this definition to, I don't know, run some cryptocurrency mining, they can only do it inside that resource group, right? They're not going to be able to bounce around your entire thing. So let's just choose the existing subscription. I'm deploying a web app on Windows. I'm just going to do that. And there is already an app service set up for me called Able Tailwind Frontend for Staging, which when I'm zoomed in, Chrome doesn't like that drop down. So those are the settings that I've got for my staging environment. I'm just deploying that application to that app service. But I don't want to just go to staging, I want to go to production as well. So let's clone that stage And now I have another one, which has got the same task in it. I'm going to call this production. I'm going to call it production. And I'm going to make one change to that task, and that's really just changing it to the production one. Oops. So I'm just going to deploy to a different app service. Now you might want to deploy to a different slot. You might want to deploy to a completely different subscription for your production environment. You have full control over this. You may even want to run some scripts, some extra things. And again, you can add tasks either from out of the box or the marketplace or your own scripts and things like that. So this is our pipeline at the moment. Every single time a build completes, and that's a continuous integration build, we're going to kick off a job to deploy to our staging environment and then automatically go straight to production, which is also not maybe the best idea. So I'm going to add a pre-deployment condition. So these are conditions that you can add to kind of give you a way of ensuring that the right stuff is working and so on before you actually push to production. There's a few different things that we can do here, but I'm going to do the really basic one, which is the pre-deployment approval. So I'm going to enable one of those, and I'm going to say, I can't spell anything at the moment, even my own name. Can somebody read my name tag for me? So I'm going to say I have to approve this move to production. So it's not going to go to production until I say that it can. So we're just going to leave it at that at the moment. So every single time there's a new build, we're going to go to staging, and it's going to wait for my approval and then go to production. But other than just saying this is good to go, I'm not copying files around, I'm not doing anything manually myself. So let's save that, and we'll go back to Azure DevOps, to our VS Code, and we'll make a change. And we'll say Tailwind Traders pipeline. Make that change, say new title, commit, push. And obviously, I'm a hardcore developer, so I'm not even going to compile this locally or try and work it. I'm just going to change stuff. The good thing, though, is if I broke it, we have this build which is going to fail, hopefully, or test will fail. So right from the start, I now have this process where I can commit bad code, but know that it's unlikely to make it to production. And this is part of the deploying safer as well. I want to build up this pipeline as much as I can to enable it to prevent bad stuff from getting to production. Right now, I'm not running any tests, so the only thing that's going to stop it is if it doesn't compile anymore, or if I notice in staging it's broken, I won't approve it to go to production, which is a decent test, right? But there's some other things that I might want to do, and we'll get to that in a second. So let's just go back to our builds and see if it's kicked off a new one. And there you go, we've got a new title build that's running at the moment. Checkout has succeeded, so this should be hopefully a lot faster than it was. And now we're doing an npm install, which is usually really quick, right? So an npm install, we'll have that build definition, we'll have a new version of our application, it'll start kicking off our deployment to staging, and then go all the way through to production. Right, so while that's going, I'll give you another quick opportunity for questions. Yes? So the question was, what's the limit of the artifacts and how many artifacts can be stored? If you're using this way of uploading artifacts from your build to just say, throw them up and attach them to the build definition itself or the build itself, I don't think they've got a limit on it right now. However, it's going to depend on your retention policy. So I'm not 100% sure on this, but I don't think they restrict it. I think they just say your retention policy basically means that these builds and the results of the build only really stick around for maybe 30 days or something like that. If you're using Azure Artifacts though, which I'm not at the moment, but Azure Artifacts is a bit more of a permanent way of doing it. So you could, instead of putting that build up as an attachment to the build, the artifact up as an attachment to the build itself, you could put it up into Azure Artifacts and say, this is my Tailwind front end version 1.3, here's the zip file. And that will stick around for as long as you need it to in Artifacts. There's a feature in Artifacts. So originally it was supposed to be NPM packages, Maven packages, and NuGet packages. But there is also a new feature called Universal Artifacts, which basically allows you to upload a bunch of files, give it a name and a version, and it will keep that as a versioned, version of whatever artifact you have. So you can upload anything really. I'm just going to skip to the release while we're doing this, and that'll take a second. Oh, there we go. There was a hand just there, yes. The question was, can you use any other artifact repository or any other artifact? Yeah, you can, absolutely. So uploading your build artifact to that artifact location, so Artifactory or something like that, that would just require you to add a new task to your build definition at the end to say, push this up to Artifactory or whatever. In your release definition, and this is completed, so I'll just show you this in a sec, but in your release definition, if you edited that, this artifact that we got here, we got this from our own build, but I could add a new artifact that comes directly from Azure Repos, GitHub, Team Foundation version control, Azure Artifacts, Azure Container Registry, Docker Hub, Jenkins. If you have a build artifact that is from, for example, Team City or Artifactory or something like that, there's likely to be an extension in the marketplace which will add a new artifact type to here. So when there is a new artifact, a version of a NuGet package in Artifactory, it will kick off a release and do that release there. So yes, you can absolutely use an existing location. Good. Can you download it from here? No, this will be just in the release pipeline that it appears. So I can see there's a question there. I'll just do this for a sec. We can see that it's in staging. It's waiting for my approval to production. So let's just quickly approve that and say good to go. And just before I hit that, let's have a look at what staging looks like. So this has the new one in it. Production does not. It just has Tailwind Traders. We haven't updated production yet until I do that approval. I can defer it for later if I wanted to do it outside business hours or something like that. But let's approve that and we'll see that it will kick off that deployment to production. So that's in process now. Question here?
How much of this can you reuse when you use a different public cloud? So say AliCloud in China.
So the question was, how much of this can you reuse if you're deploying to, say, a different public cloud? That's going to depend a lot on your application. However, your release definition, if you've already packaged up your Node application or something like that, and you just want to release it to a different cloud, then that would just be a matter of changing your release definition itself. And out of the box, we even have things, or not out of the box, sorry, but in the marketplace, we even have things like tasks to deploy to AWS, for example. Now this, I'm showing this one because it was actually the Microsoft team working with Amazon to get that task and those series of tasks out the door. So cross-cloud collaboration. So yeah, you can generally do the same build. You can generally do the same, pre-steps and so on. The actual deployment itself is likely to change if you want to go to a different cloud. All right, so that should have hopefully gone to production. Let's just refresh this. And production now has pipeline. All right, cool. That's a really basic one. So we've basically got our build compiling. We're going to staging environment. We're going to production environment after an approval, right? But I'm not really obeying the stuff that I mentioned right at the start about making sure that this is what people want. I've just deployed a new feature, right? I haven't determined whether anybody wants this feature. I don't know if I'm delivering value yet. So there are a lot of different techniques you can use to work out whether you're delivering value. And one of those techniques is doing what we call Canary deployments. It's similar to doing A/B testing or doing rollouts and things like that. But the general idea is you deploy your change to a subset of your users, watch what they do, watch if it's successful, make sure that they're happy, and if it's right, then start rolling it out to everybody else. So that's a technique that I'm just going to show you now. You can do this in different ways. I'm just going to do it using a feature of app services called slots. And I'm going to deploy to a Canary slot, and then I'm going to deploy to everybody else once that's okay. So let's jump into Azure, and we're going to add a new slot to our production environment. Now, this enables me to basically create a duplicate website or another website that I can deploy to, and then give some of that traffic to that environment. Let me just refresh this. So let's do that again. Jump to the Tailwind front end, cool. And there's a section in deployment called deployment slots. Now, right now, I only have this production slot. This is my production environment, but I can add a new deployment slot, either add slot or click here to get started. So let's do that. I'm going to enter a name. We're going to call it Canary. We don't need to clone any settings. I'm not really doing anything fancy, so let's just add that. And this will give me another location that I can deploy to. So our build is not going to change. We're still compiling the application itself, but our release will need to change. Instead of deploying straight to staging and then going to production, we're going to deploy to staging. I'm actually going to remove this pre-deployment condition, so it's going to go straight to my first environment, but I'm going to call this production Canary. And instead of deploying to that app service directly, I'm going to deploy to a slot. So in the task itself, you can say deploy to a slot or an app service environment, choose the resource group that I'm in, and then choose the slot that I just created, that Canary slot. So now this will deploy to the Canary environment. I also want to clone that environment. So we're deploying to Canary, and I'm going to clone that and just say, this is production for everyone. And I'm going to turn the slot thing off here. So we're just going to deploy to the main application. So we're going to go to staging, go straight to production Canary, and I am going to put in a pre-deployment approval before we roll it out to everybody else. So let's just save that. And I need to do one more thing. I've created this slot, but right now there's no traffic going to that slot. So let's just close this. Right now, 100% of the traffic is going to that production slot. You probably wouldn't want to do 50%, but I'm going to because there's only one of me. It makes for a terrible demo if I have to open 30 browser windows. So I'm going to move 50% of that traffic to that Canary slot. So what it means is when somebody hits that production URL, half of them are going to go to the Canary environment, half of them are going to go to production. And I can measure whether what I've delivered is successful in that Canary environment before rolling it out to everybody else. So let's just kick off a change, and then I want to explain a couple of other things about this. So let's just make a change, Canary, commit and push, make sure that actually kicks off a build. I did save that, right? Cool. So that will pick up the change in a second, start a new build and start that process again, going to staging and Canary and so on. So I did this using slots. You could easily do it with a load balancer, something like that. There are some really cool tools out there. One of the ones that I recommend, and it's not free, but it's really good, is called Launch Darkly. And it allows you to segment your traffic based on pretty much whatever you want. It's a feature flag as a service tool as well. So you can have some code in your application to say things like, if this person, go and get this particular flag. So in this case, it might be a flag called main page title, for example. So go and ask Launch Darkly, do I turn this flag on or not? Do I give somebody the new page title or do I give them the old one? And then in Launch Darkly, you can segment that person or that visitor based on whatever you want. So you could say, if they come from the Netherlands, if the traffic is coming from the Netherlands, then give them the new page. Or if this person belongs to a particular group of elite users, give them the new page. And so on. So you can start rolling this stuff out based on feature flags as well. Right now I'm doing it naively. I'm just saying 50% of them go to this new location. Facebook famously does this for all of their stuff as well. They roll it out geographically. So when they make a change, they will roll it out to, based on time zones, they'll roll it out to New Zealand first, and then along all of the different time zones. So by the time it gets to the US, it's been tested by a lot of other countries, which is interesting. Anyway, so the good thing about that though as well is if you deploy it out to New Zealand and then New Zealanders start complaining that it's not working or whatever, you can turn that flag off again and you've only annoyed New Zealanders, which is fine. So you can roll that back and then go back to the drawing board and so on. This can be really handy as well for people who are asking for a new feature, your customers who are asking for a new feature, and I know the developers in the room are likely to be familiar with this, they ask for a particular feature, but it's not exactly what they wanted. When you deliver it, they're like, it's kind of what we wanted, but it's not really right. So you could deploy this change just to those customers and then work with them to make sure it is right. They're testing it in production for you, but nobody else is affected, just those customers themselves. So it's a really good way of actually verifying that you're delivering value before you deploy it out to production for everybody else. So this is clearly one of the slightly slower ones, and we're going to be at 66% for a while. So I want to just talk about one of the other things that you can do here. So we in here, we just deployed a single node application to the front end, to an app service, all right? In general, you'd probably have much more complexity in your application. You'd have a database in the back end. You might have a second application. You might have some microservices that you want to deploy maybe at the same time. You might have a number of different projects that need to be compiled. So here's an example of the Tailwind, and this is the all-up one. So we actually have an inventory service. So this is another repository, comes from somewhere else. And it's a .NET Core application. So we're doing a .NET restore. We're doing some bash scripts. It's .NET Core, so we're still running this on an Ubuntu agent, I believe. Yep, no, we're actually running it on hosted VS 2017, but we're still running bash because WSL allows us to run bash on Windows. So we're doing some .NET stuff. We're running some tests. We're doing some functional tests. We're building a Docker image. And then we're also defining an ARM template to define the environment that this runs on too. And then we're uploading that as an artifact. So that's one service. There's another service, which is building a Docker image and using Helm to deploy a chart so we can deploy to Kubernetes. We're using the front end. This is the one that we've just seen. So this is the NPM application. We're even doing a mobile app for for iOS. So this one actually uses a hosted Mac agent pool. So we're building it on a Mac from Azure DevOps to deploy to mobile phones, to iOS phones. We're even doing things like installing provisioning profiles from Apple certificates and things like that. And then we're copying files to published directories, we're uploading them and so on. So the result of this is that we get several artifacts. We're building each thing individually and saying these are the artifacts we want. And it means that when we do our deployment, we have this one drop location which contains lots of different artifacts, but we have parallel pipelines for release. So this is one way we could do it. We might want to tie them all in so they all got released at the same time. But here, we're deploying the inventory service. We're doing a blue-green deployment, which basically means stand up a new environment, deploy to that environment. Sorry, have two environments. Deploy to one, and then if it works, switch the traffic to that one. And then the next time you deploy to your green environment and switch the traffic back. And the next time you deploy to your blue environment, switch the traffic back. It's another technique for maintaining uptime. And then we're going to production. Our product service is going to a dev, staging, and production environment. Our web front end is going to staging, prod A, and then prod B, so we're doing kind of a Canary deployment there. And our iOS app is going to a dev environment, a beta environment, using test flight to deploy to our beta testers, and then going to the store. So we have a lot of freedom in what we're actually doing in our deployments. We can deploy all of that kind of stuff. All right, we've finished that one, so hopefully we'll be able to see that. We're deploying to staging at the moment, so let's follow that along. And we have deployed to staging. So now we are queued to deploy to the production Canary environment. So staging, if we refresh, should look like this. We have Canary in there, which is great. So we've deployed to staging. Production, though, is going to be a bit more complicated. Production right now, when I hit it from this browser, is showing me the old website. Right? We are deploying to the Canary one at the moment. So I just happen to know that this one is hitting the real production site, right? So when this deploys to Canary, this is not going to change. This production site is not going to change, right? But if I hit it from a different location, a different device, something like that, I'm going to end up getting that Canary site. So let's just wait until this finishes. There we go. So we've got a deployment to staging, a deployment to production Canary, and then it's waiting for my approval to go to production. So here, when I hit production, it's not refreshing, and I've had that problem before. Let's try this. Oh no, sorry, that is the production one, so that is correct, sorry. That's the existing production site. I want to hit it again, let's try this. Let's try doing it in Safari. And we get the same thing. Cool. Let's do an incognito Safari. This is the problem with having just 50% of the traffic. It's non-deterministic, which means that these demos can go really, really well. So now we're hitting the front-end website. Okay, but we've got that change. So I've hit the production URL from a Chrome browser, and then I've hit the production URL from an incognito Safari browser or a private browsing Safari browser, and I've got a different result. So I can look at the people who are hitting this new location and find out whether there are any complaints about it. If there are not, I can just approve that, say this looks good, and that will roll out to everybody. So production will start seeing that new feature that I just deployed as well. So this gives me another way of making sure that what I'm deploying is not just working, but is also valuable for people. I can determine whether that person is doing whether the application that I've just deployed is doing what people want it to do. So there's one more thing I want to do. I mentioned before, I made a comment that comes from my boss, never send a human to do a computer's job, right? This is a manual approval for me to look at staging or look at that production Canary environment and say, this needs to go to production. So I don't want to do that. There are ways that I can determine whether it should go to production without a human intervention. So let's just take off this pre-deployment approval, and I'm going to add a deployment gate. Actually, I'm not going to do that here. We'll just do it here because I need to show you the end purpose anyway. We're running out of time. So I can add a deployment gate, and this is like an automated approval process before it'll go to production. And there are a number of different gates that I can use that come out of the box. So I'll start from the bottom. I can do a security and compliance assessment over the resources in Azure to make sure that they are meeting my security requirements. And if they're not, I will not deploy this application to production. So I can check for this stuff before going on. If it does comply, then I can move on to the next gate or the next approval, or I can just go straight to production. I can query work items if I'm using Azure boards to work out the work that I'm doing, and maybe not deploy to production if there is an open severity 1 issue for my application. I probably want to fix that first. I could have a look at Azure Monitor alerts. So have a look to see whether there are exceptions or more exceptions than I expected, or the performance has decreased or something like that. And then these last two give you pretty much full reign over whatever you want to do to verify that your application is working. So you can hit a REST API and make sure that that gives a correct response, or hit an Azure function. So by way of example here is an example of something that Abel did. He worked at a hospital or did some work for a hospital where they had a hard and fast rule that you had to have a document signed, right, before it could go to production. So he convinced them to use DocuSign. So as this gate, so it goes to a staging or pre-production environment, and it will hit an Azure function which hits the DocuSign API and has a look to see whether that document has been signed. Not signed there, not signed 5 minutes later, was signed 5 minutes after that. All right, go straight to production. So hands off on a day-to-day basis, but you're still making sure somebody has physically signed that document. There's another one as well that he's worked on where he wrote an extension for Dynatrace, which is a performance monitoring tool. And if Dynatrace has a look at what's deployed right now and says the performance has dipped by whatever threshold I care about, this is not good enough to go to production, right? This application is now too slow. It doesn't hit our thresholds for how fast it needs to be, so just don't go to production. In this case, of course, it was fine, so we went to production. But in this one, that gate did not pass. We had too many exceptions, or it didn't perform well enough, so we just stopped it from going to production. And again, really hands-off for this stuff as well. So there's a lot more that you can do here to make sure you're deploying not only faster, but safer as well. We're running out of time, and I have to actually go to a session straight after this, but at 2 p.m. in the hub, in the Experts Center, I will be sitting there, standing there, answering questions. I have a pile of stickers as well, if you want to come and grab them. So that's 2 p.m. today. If you want to look at this stuff right now, Azure DevOps Docs has some amazing walkthroughs of how to do all of this stuff. There is also another document called the DevOps Resource Center, and it's not just Azure DevOps itself, it's DevOps in general and Agile in general. These slides are as well are available, so I can see some people taking photos. This is the one to take a photo of, but this applies for every session as well. So aka.ms, my MS Ignite, the tour, will get you all of the session presentations and things. And then your session code, or the code that we use for all of these learning paths, is on GitHub as well. So you can go and have a look at those whenever you want. Make sure you fill out the feedback forms. That's really, really valuable to us as well. And I do have to go to another session, so I can answer questions in the hub at 2 p.m. today. Other than that, thank you very much for your time. I hope you have a great rest of your day.